Here we see another STEM project of designing something. In this case, we're going to design a solar hot dog cooker or a marshmallow cooker, whatever you want to call it. First of all, we've got a pizza box here from Pizza Hut. And of course, everybody loves Pizza Hut pizza. It's really good pizza. And they're nice enough over there that they might give you an extra box or two, if you buy a pizza. So, this is a really good box to do this with. What I did was I put some black paper in here because we know black actually absorbs all the colors from the electromagnetic spectrum. Black itself, I understand, is not even a color. There's no reflection there. All colors are absorbed into it. Just a little trivia there. White is not a color either. All things are bounced off of objects. Even like in the sky, clouds have white appearance, even though we know they're water because all the electromagnetic spectrum rays of the Ray-G-Biv spectrum, they all bounce off. And so when they all bounce off, it looks white. So anyways, just a little trivia there, but that's my understanding. In this case, we're going to put down black to absorb more heat from the sun. So once we do that, we're going to close this up. I'm going to have to turn this around, so excuse me just for a second. And we're going to tuck this in like this. And then we're going to measure. And what we want to do is we want to cut out something that goes up, like a lid on a washer or something. So we're going to do some measurement. And in fact, I'm going to come in here so far, and I'm going to come in about 3 inches or so. And I'm going to next there. I'm going to come in another 3 inches here. Do this, and then I'm going to come in another. I'm going to go 2 inches on this one, right here. 2 inches here. And we're going to do 2 inches here. And then 2 inches here. Okay, now, lid opens this way. So what we want to do is, we want to go up to this direction, since the lid is going to come up this way. We're going to go up here, make a line. We're going to come over here and make another line. We're going to come down here and make another line. So in this particular STEM exercise, what we're doing is we're using linear measurement, or we're going to be using measurement with temperature. You can use a thermometer, or I have an actual temperature gun, so to speak, that will measure it. So I'm going to put lines here, just dotted lines like this, so I don't get talking and then accidentally make a cut where I don't want to remind me of that. So we're going to take, this is some kind of a box cutter. I'm not sure what the exact name is, but I do know this, that this is something where adults will want to definitely cut this box. A teacher or parent, please, 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 kids, do not use this on your own. You think you can, but it just takes a little swipe and you can take a good slice of your finger, if not worse. So please take this from Mr. McWhizzle. Do not use one of these on your own. Let an adult do that. So what I'm going to do here is I'm going to put this in here like this. I'm going to slice this down this way. And then I'm going to do the same thing here. Sometimes I make it a little smaller at first. That way. No, I'm just kidding. We're going to go over here. And we're going to slice this one this side. So now, always close these up. We're going to open this up, and you can see that we have our lid. Now, sometimes what I do is I score it a little bit right here, and the reason I do that is just so that it'll open up where I want it to. So I'll put a little bit of a score here. that. So we're going to open it up, see how it scores nicely like that. So far, I think everybody can see this okay. Any questions? Anyways, we're going to now take and put this aluminum foil so that when we actually pull this up, we're going to want the aluminum foil to be especially around this side right here. Okay. So what I do is I'm just going to take this and take the more reflective side, and I'm going to come around this way with it. Actually, this way first, like that. And then I'm going to take and open that up and bring this around like this. Okay, so now we've got a couple of choices. I'd rather use scissors on this, but we're going to cut right about there. Do the same thing on this side. Now you got a couple of choices here. Duct tape works pretty good. I'm going to actually make this even neater. I'm going to cut this. Sometimes aluminum doesn't cut too well. In this case it did. Make it nice and neat. So now we're going to take some duct tape, and I'm simply going to put some across here. I think we'll go this way first. And we'll make it nice and neat. This right here. Another one here. All known rules. There we go. Okay, so far you see we have. Okay, now what I want to do is I want to also put some back here. So everything stays nice and fairly neat. It's always nice to take pride in your work, and I know all of you like to take pride in your work as well. Okay, so now once you have it like that, then you probably want to open this up, and you want to take this part right here too. Perfect. All right, so now that's taped. Okay. So now next what we want to do is this. We want to take and we want to put some saran wrap over the top of this. Okay. And what the saran wrap will do, you could probably guess, the saran wrap will actually trap, hopefully trap the heat in, because we want to get it hot enough so obviously the hot dog or the marshmallows will cook. So I'm going to take about this much, and you know what saran wrap is like, or stretch tight wrap, or whatever brand you get. It will stick really easy to things. So what we're going to do is we're going to take and we're going to maybe get a friend. This is where it's nice to work with a friend or parent on this. You got somebody else to hold it for you. And so I'm going to put this right here. Like that, and I happen to have a piece of tape right here. So we're going to put some tape right there. And we got another piece of tape right here. And then we're going to stretch this out like this. We're going to pull this side. This is where, again, having an extra hand helps. This one happens to be a little bit too long, so I'm going to take and just cut it a little bit. There. And on this one, I like to tack it down and then pull it a little bit. Okay. So the only thing that remains is basically this part right here. And that's a little bit tricky. We're going to try to see if we can't get some of that. All right, so there we've pretty much secured the saran wrap over the hole, and now what we're going to do is this. We're going to take and I'm going to actually set this up the way it's supposed to be, and we're going to tuck this in like that. And this is like this, so you can see. Okay, so there, so far is our solar hot dog cooker. And the next thing we want to do is this. In order to get this to stay up, you have to design something. Again, this is all about designing. So in STEM, which is of course science, technology, engineering, and math, a lot of people when they look at the T, technology, they think of computers and robots and all that kind of thing. But in actuality, in the STEM definition of technology, it's really any apparatus or device or something that makes life easier for us as human beings that we would design that would be useful. And so any kind of a product that you would make that would be very useful to human activity would come into that category. In this case, designing a solar cooker. Now, we don't have any electronics here, but it certainly is designed, and we hope that you can design even a better one perhaps than we've made here. But it's a lot of fun, and we're gonna continue just by showing you this. Depending on the reflection of the sun. The sun might be at one part of the sky, or it might be another part of the sky, so you want to make this movable, and that's the purpose of the movability factor. So what I do is I simply puncture holes in different places here, and I might puncture 1, 2, 3, or more. You might want to puncture more. And that way, if I put it in one of these holes and it's, say, more towards the end of the day, I can set it up like this, and the sun might hit at a certain angle and then reflect down into where the marshmallow or hot dog is being cooked. But at that point, what you can do is you can have one of these. This one happens to be a Radio Shack, which is really a good one. I like it. It actually will measure the temperature inside. Now you could put a thermometer in there. This one I find is really nice because you can use it for a lot of experiments, and we're going to just turn it on and show you a little bit about it. And when you actually hit this trigger right here, like that, and you do this, you should be able to get a reading. Like this one says 24.8. You probably can't see that, but 24.8, almost 25 degrees, and that would be in Celsius. Now, if I hit this button right here, I have it in Fahrenheit, 77 degrees. That's what I like about it, so I can get both, Celsius and Fahrenheit. So now what we would do is we would hold this on here and maybe do a starting, a starting reading on it. And then when we do that, we would then see how long it takes and maybe even graph that over a period of time before it gets hot enough to actually either, toast a marshmallow, at least a little bit, or, you can might make a s'more or, whatever you like to do, or maybe start cooking a hot dog. I think actually back in the 70s, if I remember right, I know some of you don't go back that far, right? But people used to put these in the back behind their seats on where the window was, and while they were driving, they would actually, if they were in a hot car like in Arizona or someplace, they would actually cook their hot dog while they were driving. That's really something. So you may want to get one of these, but you might want to, take temperatures at different times, like every 15 minutes or every 30 minutes, and then check your hot dog and write down your results. Maybe put them in a table, and if you're an older student, more advanced, you can actually plot your X and Y coordinates on a graph. And then you can take a look at this and say, okay, my problem is my hot dog's not cooking. And how do I make a better one? Is there anything I can do to this to make it even hotter in there so that the hot dog will cook better? Can I redesign this part here? Can I redesign the inside in some way? What can I do? And then test it. And then, get the results, talk about it collaboratively with another person or other students, and then redesign it, get some ideas, and then, make your other prototype, and then test your prototype, and see what the results are, and then experiment, and then collaboratively discuss the results and see if you need to redesign it again. But a lot of STEM is all about trial and error and about making improvements by redesigning and making it technologically better. And so that's what our technology is all about here. Anyways, I hope you enjoy this design opportunity with our STEM activity.